Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this video, we're going to learn all about percent composition and how we can determine it for a compound. Let's get started. When you're asked to figure out what the percent composition of a compound is, oftentimes what they're looking for is the mass percent composition of each element that's found there presently. So what you're going to have to look at is we'll determine exactly what amount is accounted for by a single type of element in the compound versus the entire whole of the compound. And so often when we're writing percentages, we're looking for some part to whole ratio where the part represents the element in question and the whole will represent the entire compound's mass. And so for percent mass composition, we're looking at the mass of an element compared to the mass of the entire thing. And so in this case here, it says find the mass percent of chlorine in C2Cl4F2. And so we see that there are 4 chlorines. And so chlorine's mass by itself is 35.45 AMUs, or atomic mass units. And in this case, we actually have 4 of them. So the total mass coming from chlorine would be 35.45 times 4. And so that gives us 141.8 grams of chlorine that's present. The total compound would be carbon's mass, which is 12.01 times 2, plus chlorine's mass of the 35.45 times 4, plus fluorine's mass, which is 19.0 times 2. And so we would have to add all that up to represent the whole mass of that compound. So let's go ahead and do that. So we have 12.01 times 2 plus 35.45 times 4. You could just as simply have plugged in the 141.8 plus your 19 times 2. That gives us a total of 203.82. To find the mass percent of chlorine, it would just simply be 141.8 divided by 203.82. And it's a percent, so we're going to multiply it by 100. And in that case, we end up with 69.57% chlorine. So if we did some elemental analysis on this compound, the bulk of the mass is actually coming from the chlorines that are present. And the next problem, it says, determine the mass percent composition of the following. And so you notice it doesn't say which element it's looking for, so we're going to solve it for both. But the fact that there's only 2 elements, that really helps us out because the sum of the mass percents, when we add them all together, should add up to 100. So if I know the mass percent of one of them, I can therefore figure out the mass percent of the other. So with calcium, that's the one I would choose because there's only one. With calcium, we know that its mass is 40.08. And when we are calculating the mass of the entire thing, we would do 40.08 plus 35.45 times 2 to represent the fact that there's 2 chlorines. So let's go ahead and figure out the total mass. So that would be 40.08 plus 35.45 times 2. And that gets us 110.98 as the total mass. And so if we wanted the mass percent of calcium, that would be its mass, 40.08, divided by the total mass of the compound, times that by 100. So we end up with 40.08 divided by 110.98. And then we multiply all that by 100, and we get 36.11 as your percent calcium. So a quick way to get the percent for the chlorine would just simply take 100 minus 36.11 because there's only those 2 compound or elements found in the compound. And that would give us 63.89% chlorine. If you weren't sure if that was the case, you could also do the calculation for chlorine. But instead, we would put its mass, so we'd have 35.45 times 2 on top, so that's 70.9, divided by the total of 110, multiplied by 100. And when we do that, we would take 70.9 divided by 110, and we end up with 63 0.89% for chlorine. And so we see that either way that we do it, it checks out. So two different formats for you to think about. The great thing about this is if you know the mass percent of something, you can actually use that as a conversion factor. That allows us to go from, say, maybe talking about information about the entire compound to one particular element within that compound by looking at the mass percent as a conversion factor. And so what that means is the mass percent is really telling us how much of each element is present if I had 100 grams of that compound. So for instance, if I say I have 58.64% chlorine by mass, that means if I had 100 grams of this entire compound, 58.64 grams of that would be chlorine. So we're just simply taking this and making it the gram amount of the individual set to the mass for the entire thing. Well, that becomes a conversion factor that we can use. And so if I was trying to convert from one thing, or from talking about the individual to the whole or vice versa, I can now plug that in based on the desired needs for this problem. And so if we look here, it says find the mass of table salt containing 2.4 grams. And there should be a little bit of information given to us, is the fact that the mass percent of sodium is 39%. And so table salt, we know that is a formula of NaCl. And so we want to figure out what mass of NaCl is present that would contain 2.4 grams of Na. Now, because we have this mass percent, we can simply do this in one step. What we're looking for is a means to go from this to this. And so when we're going from grams to grams, that's where a mass percent is useful. So if it's not given to you, if you know the formula, you could actually first figure out what the mass percent of the element is and then use that. And so we're just going to translate that into a conversion factor where I can say from grams of sodium, and I want to get to grams of NaCl. Well, what that mass percent says, for every 100 grams of this total compound, 39 is sodium, and that becomes our conversion. If you go ahead and plug that in, you would say 2.4 times 100 divided by 39, and what we end up with is 6.2 grams of sodium chloride. So if we had 6.2 grams of sodium chloride, 2.4 of that would be your sodium. Okay, let's try another one. It says benzaldehyde is 79.2% carbon. What mass of benzaldehyde contains 19.8 grams of carbon? So again, we don't know what benzaldehyde, we don't know the formula, but we do know the mass percent. And so that's what will help us to solve this problem. And so it says we are starting with 19.8 grams of carbon, and I want to know what mass of benzaldehyde would contain that. Well, again, I'm doing grams to grams, so that means I should be able to use this mass percent as a conversion factor. And so I would take my grams of carbon on the bottom. I would take my grams of carbon on the bottom, and on the top would be grams of the benzaldehyde. And I'm going to input that mass percent as a factor. So that tells me that there's 79.2 grams of carbon for every 100 grams of that benzaldehyde. When we plug that in, we get 19.8 times 100 divided by 79.2. And what that ends up getting us is 25.0 grams of the benzaldehyde. Okay. I hope this information helped you understand how to actually use mass percent as a conversion factor and how to even calculate mass percent. Be sure to come back for more videos. Make sure you like, comment, and subscribe, and let me know what you want to see from videos in the future. Have a great day. I'll see you guys soon. Bye.